In this question, we are given a quadratic equation x square plus 4kx plus k plus 3 is equal to 0, and we are told that both the roots of this quadratic equation are real and less than 4. We are given 4 options for the value of k, and we are required to find out which of the 4 options is correct. Now, if you are given a function f of x, which is of the form x square plus 4kx plus k plus 3, and if you are told that both the roots of this quadratic equation are less than 4, then the curve will look something like this. This is the y-axis and this is the x-axis. This is say x is equal to 4. Then the quadratic equation will look something like this, where it will achieve its minimum point before 4 and will again rise above the x-axis. That is, at this point where you substitute the value of 4, the value of f of 4 will be greater than 0. Similarly, the point at which the quadratic equation will achieve its minimum, that is minus b by 2a, will also be less than 4. Both of them should be on the left hand side of the value x is equal to 4. What is the significance of this minus b by 2a? When you are having a function x square plus 4kx plus x plus 3, it will attain its minimum when x is equal to minus b by 2a, where b is the coefficient of x and 2a and a is the coefficient of x square. In this particular case, what is the value of minus b by 2a? This will be equal to minus of b is equal to 4k, which is the coefficient of x, divided by 2a, which is equal to 2. So this is equal to minus 2k. So we need 3 conditions to be satisfied for the roots of the quadratic equation to be real and less than 4. The first thing we would need is that the discriminant of this quadratic equation is greater than or equal to 0. This would imply that both the roots are real. The next thing we want is that the minimum point of this quadratic equation, which is attained when x is equal to minus 2k, this has to be less than 4. And the third condition that needs to be satisfied is that at 4, f of 4 has to be greater than 0. That is, the quadratic equation should attain its minimum and then again come back above the x-axis. So you want f of 4 to be greater than 0. Let us consider all the 3 one after the other. Let us first look at the first condition, that d has to be greater than or equal to 0. What is the value of d? If you have a quadratic equation which is of the form ax square plus bx plus c, the discriminant is b square minus 4ac. In this case, the value of b is 4k, so b square will be 16k square, has to be greater than 4 times a, that is the coefficient of x square is 1 and the constant term is k plus 3. So 16k square has to be greater than or equal to 4 into k plus 3, or 4k square minus k minus 3 is greater than or equal to 0. If you simplify this, you are going to get 4k square minus 4k plus 3k minus 3 to be greater than or equal to 0. This would imply that 4k plus 3 into k minus 1 is greater than or equal to 0. The two roots of this quadratic equation are minus 3 by 4 and 1. So k has to be either less than or equal to minus 3 by 4, or k has to be greater than or equal to 1 for the first condition to be satisfied. What will happen for the second condition? If you want minus 2k to be less than 4, minus 2k has to be less than 4. So minus k has to be less than 2, or k has to be greater than minus 2. This is the second condition. This also has to be satisfied. What is the third condition? The third condition is that f of 4 is greater than 0. That is, when you substitute the value of 4, this should be greater than 0. So if you are substituting the value of 4, this is x square is 16 plus 16k plus k plus 3 has to be greater than 0. Or you want 17k plus 19 to be greater than 0. Or you want k to be greater than minus 19 by 17. So you want k to be greater than minus 19 by 17. You want k to be greater than minus 2, and you want either k to be greater than minus 3 by 4 or k to be greater than 1. You want either k to be less than or equal to minus 3 by 4 or k to be greater than or equal to 1. So if you are looking at all the options, the first option says that k has to be between minus 2 and minus 13. This is clearly not true, because there is a blank time over here between minus 3 by 4 and 1. For example, if k is equal to 0, this is not satisfied. So if you are looking at all the intervals for which this has to be satisfied, the first thing is that k has to be greater than minus 19. So k has to belong to either minus 19 by 17 to minus 3 by 4 union 1 to infinity. This is the values that k can take. It can belong to either minus 19 by 17 to minus 3 by 4, union of 1 to infinity. So if you're looking at all the options, the first option doesn't satisfy it because there is an interval from minus 2 to minus 19 by 17 and an interval between minus 3 by 4 and 1 where this is not satisfied. If you're looking at the second interval, this is between minus 1 and minus 3 by 4. As you can see, all of them are part of the interval in which k is allowed. So this is actually true. If you're looking at the third option, you want k to lie between minus 2 and minus 3 by 4. Again, there is an interval between minus 2 and minus 19 by 7 where the values of k are not satisfied. So this is also not true. And finally, if you are looking at minus 1 by 4 to 13, there are many intervals, especially between minus 3 by 4 and 1, which lie in the given interval in which k should not fall. So this is also not the correct answer. Essentially what we are saying is for all values of k which lie between minus 1 and minus 3 by 4, the roots of the quadratic equation x square plus 4kx plus k plus 3 is equal to 0 will be real and both of them will be less than 4.